What if I told you that one of the richest and most technologically advanced countries on Earth is still moving cargo with trucks that look like they escaped from the 1980s? Massive chrome bumpers, giant vertical exhaust stacks, long noses stretching across the highway like mechanical dinosaurs. Meanwhile, in Europe, trucks look completely different. Smooth, compact, aerodynamic, almost futuristic. So why does America still build trucks that look 40 years older than European ones? Is it just culture, style, tradition? Or is there a hidden engineering reason that completely changed the evolution of trucking forever? Because once you understand the brutal reality behind American roads, fuel prices, crash laws, engine heat, sleeping conditions, and logistics economics, you realize these trucks are not outdated by accident. They were forced to evolve this way. And the reason starts with something most people never think about: distance. In Europe, countries are packed tightly together. A truck driver can cross multiple national borders in a single day. Fuel stations are everywhere. Repair centers are close, cities are dense, roads are narrow. Everything is optimized around efficiency. But America operates on a completely different scale. A truck leaving Texas might drive for days before reaching its destination, thousands of miles. Empty highways, extreme heat, freezing mountains, massive cargo loads, long periods without stopping. And those brutal distances completely changed what trucks had to become. European trucks evolved like precision tools. American trucks evolved like survival machines. The first major difference appears instantly the moment you compare them side by side. The cab design. European trucks use what is called a cab-over-engine layout. The driver sits almost directly above the engine itself. That design shortens the entire vehicle dramatically. Why? Because Europe has extremely strict overall vehicle length laws. The shorter the truck, the longer the trailer can be. And in logistics, trailer space equals profit. Every extra foot of cargo space matters. So European engineers sacrificed hood length to maximize freight efficiency. But this creates serious trade-offs. The engine is packed tightly underneath the cabin. Heat builds aggressively. Repairs become harder. Long-distance comfort suffers. And crashes become more dangerous because there is less front-end crush space. American trucks went the opposite direction. Long-nose conventional trucks dominate American highways because U.S. regulations historically focused more on trailer length than total vehicle length. That gave manufacturers freedom to stretch the front section outward. At first glance, it looks inefficient, but that long hood secretly solves multiple brutal problems at once. First, cooling. American trucks often haul enormous loads through deserts where outside temperatures can exceed 110 degrees Fahrenheit. A giant nose allows for massive radiators, better airflow, and larger cooling systems. Without that extra space, overheating becomes a serious threat, especially when pulling 80,000-pound loads uphill for hours. But cooling is only part of the story. The second reason is maintenance. A European cab-over truck often requires tilting the entire cab forward just to access major engine components. But American trucks allow mechanics to simply open the hood and reach the engine directly. That matters enormously when a truck is operating hundreds of miles away from a major city. Downtime destroys profits. If a truck sits broken for 2 days, the company loses money every hour it cannot move freight. American trucking evolved around repair speed and mechanical accessibility. And then comes the biggest difference of all: the driver. Most people completely underestimate how truckers actually live. In Europe, strict labor laws often limit driving hours heavily. Drivers stop more frequently, trips are shorter, infrastructure is closer together. But in America, long-haul trucking can feel like surviving inside a moving apartment. Drivers may spend weeks on the road, sleeping, eating, living, working, all inside the truck. That massive long-nose design allows for enormous sleeper cabins with far more interior comfort. Large beds, storage space, microwaves, mini refrigerators, climate systems. Some trucks practically become portable homes, and when your entire life exists inside a machine, comfort stops being luxury. It becomes survival. But then another invisible factor changed everything even further: fuel prices. Fuel in Europe is dramatically more expensive than in the United States. That single economic difference completely reshaped truck engineering philosophy. European companies became obsessed with squeezing every possible mile from every drop of diesel. That obsession created ultra-aerodynamic truck bodies, rounded edges, Airflow channels, compact profiles, low drag designs. Even tiny fuel savings matter when operating massive fleets. Meanwhile, American fuel remained comparatively cheaper for decades. So trucking companies prioritized durability, engine size, and driver comfort more heavily than extreme aerodynamic optimization. That is why American trucks often use enormous engines with terrifying touring torque out. These machines are designed to pull huge loads across giant distances without dying. And then there is something even more important: roads. European roads are ancient. Many streets were originally designed centuries ago. Tight corners, tiny roundabouts, dense cities, compact industrial zones. A massive American-style truck would struggle to maneuver through many European environments. But American highways were practically built for gigantic vehicles. Wide lanes, huge interstates, long open stretches. Different infrastructure created completely different truck species. But now something strange is happening. The trucking world is starting to change. Modern fuel regulations, emission laws, electric drivetrains, aerodynamic demands. American trucks are slowly becoming more European, and European trucks are slowly becoming more digital and automated. The old mechanical giants are disappearing. Some trucking veterans believe the golden era of analog trucking is dying right now. Because modern trucks are no longer just engines and steel, they are computers. Software-controlled transmissions, digital monitoring systems, remote diagnostics, driver tracking systems, automated safety interventions. The truck is becoming part machine, part rolling data center. And that shift is making many old-school drivers deeply uncomfortable. Especially those who still remember when trucks were designed to survive forever with basic tools and mechanical knowledge. Today, a sensor failure can disable an entire fleet via a software issue can strand a truck hundreds of miles from home. And some mechanics argue modern trucking has become too dependent on fragile electronics. Ironically, the futuristic European approach that once looked more advanced may now be creating its own new vulnerabilities. And suddenly those old American-style mechanical trucks no longer look outdated. They look resilient, simple, repairable, understandable. The real answer to why American trucks look 40 years older than European ones is not because America is behind. It is because these trucks evolved under completely different physical realities. Different roads, different fuel costs, different laws, different distances, different lifestyles. Europe optimized for efficiency. America optimized for endurance. And once you understand that, those giant chrome machines stop looking old. They start looking like survivors. Because in the brutal world of long-haul logistics, the truck that survives the longest usually wins. And maybe the strangest part of all is this. As the entire industry races toward automation, electric fleets, and software-controlled transportation, the old mechanical trucks everyone once mocked may become the last machines that drivers can truly understand, repair, and control themselves. The question is no longer which design looks better. The real question is, which philosophy survives the future?